Well, this is the problem of arrangement of the letters of a particular word with different restrictions. So, how many ways of the letters of the word remand are possible if there are no restrictions? They begin with RE, they do not begin with RE, they have RE together in order, they have REM together in any order, R, E, and M are not to be together. So before going into the solution, let's first discuss whether here order matters or not, or repetition is allowed or not. So as I have told you before, whenever we have the word arrangement, it means it relates to the order matters. That's why different arrangements are possible. So here the order matters, and this is the case of repetition is not allowed here because once the letter is chosen, so it can't be repeated. So repetition is not allowed. So whenever we have these two situations, we use permutation. So we would use permutation in its all parts. Let's now go through the different parts. How many arrangements of the letters of the word remand are possible if there are no restriction? So now here is no restriction to arrange the letters of the word. So here we have in total 6 letters R, E, M, A, N, and D. So we have to arrange these 6 letters. So for the first place, we have 6 possible choices to choose from these letters. So now here at the first place, we have chosen 1. So for the next place, we are left with 5 letters. For the third place, we are left with 4 letters to choose from because the 2 are already chosen for the first and second place. So for the fourth place, we are left with 3 letters. For the fifth place, we are left with 2 letters. And for the last place, we are left with only 1 letter. So it is basically 6p6. We have to arrange 6 letters in 6 places. So it is 6 factorial, which is in 720 ways we can arrange these letters in different arrangements. How many arrangements of the letters of the word remand are possible if they begin with RE? Now we have to arrange the letters of the word remand that it began with RE. So now here RE is pre-selected, so we have no concern with the arrangement of these 2 letters at this place. This place is fixed with these 2 letters. So we have to arrange the rest of the places. We have to arrange the letters for the rest of the places. So here we have 4 places and we have 4 letters because R and E letters are already used in the first 2 places. So out of 6, we are left with only 4 letters to arrange in these 4 places. So it would be 4p4, which is 4 factorial, and it is here we have 24 different arrangements for the letters of the word remand as it begin with RE. How many arrangements of the letters of the word remand are possible if they do not begin with RE? So here we have to find the arrangements which do not begin with RE. So in the previous parts you have seen we have calculated the total arrangements without any restriction, and then we have in B part we have calculated the arrangements for the words which begin with RE. So the total arrangement consists of 2 parts. One part there are begin with RE, and the second part they aren't begin with RE. So we can write it as the arrangements do not begin with RE is basically the total arrangements minus the arrangements begin with RE. So the total arrangements R6P6, and the arrangements begin with RE, R4P4, as you have seen in the A and B parts. It is basically 696 arrangements for the letters of the word remand which do not begin with RE. How many arrangements of the letters of the word remand are possible if they have RE together in order? Well, now we have to arrange these letters as RE stay together here in order. In order means it can't be ER, it has to be in order RE, that's first R, then E. So we have to place them together wherever they have to place, like it can be here, it can be here, but they have to be together like this. So as we have to place them together, we would consider RE as one unit. So here we have 1, 2, 3, 4, 5 units, 5 places in which we have to arrange 5 letters. You can see we would consider RE as one unit, one letter. So here we have 5 different ways to arrange them as RE stay together. So this is basically 5 factorial, that is 120 arrangements are possible so that RE stay together. How many arrangements of the letters of the word remand are possible if they have REM together in any order? Here we have to arrange them like REM have to be together but in any order. So it can be ERM, MRE, and so here you can see we can also arrange REM in different ways, in different orders. So here REM, we have 3 letters and we have to arrange them in 3 places. So we can arrange them in 3 different ways. Now we would consider this REM as one unit because they have to be stay together. So whenever any different units are supposed to be stay together, we would consider it as a single unit. Now we have 1, 2, 3, 4 places and we have to arrange 4 units in 4 places. REM, we would consider it as one unit, and then A and D. So in total we have 4 units and 4 places. So we can arrange them in 4P, 4 different ways. So here we have 3P3, 3 factorial, and 4P4 as 4 factorial. So there are 144 different arrangements that REM would stay together in any order. How many arrangements of the letters of the word remand are possible if RE and M are not to be together? So you can see in the previous part E, we have calculated the total arrangement in which REM can be together in any order. So we can say here that the total arrangement without restrictions are basically consists of 2 arrangement with REM together and REM aren't together. So we can write here arrangements in which RE and M are not to be together is basically the total arrangements minus arrangements they have REM together in any order. So here the total arrangements are 6 factorial and the arrangements they have REM together in any order as in the previous part E. They are 3 factorial multiplied by 4 factorial. So we have 576 different arrangements in which REM are not to be together.